Hello, I am Ritu Arbendre, currently pursuing my Masters in Indian Institute of Engineering Science and Technology, Howrah. Today we are going to discuss about the topic of differentiation. At the end of this video, we are going to learn the following. That is, we are going to construct the definition of differentiation, we are going to derive the basic formula, and lastly, we will be looking at one previous year question. So, what is differentiation? Differentiation is all about slope. So, slope of straight line is very well known to us. So, what is slope of a straight line? It is nothing but change in y divided by change in x. That is, if y1 and y2 are coordinates in y-axis and x1 and x2 are coordinates in x-axis, then slope is defined as y2 minus y1 divided by x2 minus x1. It was pretty simple. Now, my next question is, can we find slope of a curve? Is it possible for us to find slope of a curve? So, slope of a straight line is very easy. So, my next question is, can we find slope of a curve? So, for a slope of curve, let us consider 2 points. If I consider 2 points in a curve, I will get the absolute slope, right? I will not get the definite slope of a curve, but I will be able to find the absolute slope. Now, my final question will be, can we find slope at a point? Is it possible for us to find slope at a single point? So, the point of consideration of mine will be p of x comma f of x. So, if I just zoom this point, if I just get a wider picture of this point, so the point will be p of x comma f of x. The very next point of this p is q. Very next point in the sense it is very close to p, the neighboring point of p. So close that the distance between them is almost negligible, and the distance between this p and q is here considered to be delta x. So if this point p is x comma f of x, the neighboring point q will be x plus delta x comma f of x plus delta x. So when these two are the point of consideration, we can consider it to be almost a straight line, right? Since it is very close to each other, p and q are very close to each other, therefore I can consider this to be a straight line. Now slope between these 2 points will be given as y2 minus y1 divided by x2 minus x1, which in turn gives us f of x plus delta x minus f of x divided by x plus delta x minus x. Here x and x get cancels. We will be left out with f of x plus delta x minus f of x divided by delta x. And hence, slope is given by f of x plus delta x minus f of x divided by delta x. Then what is differentiation? Differentiation is nothing but slope at point. Since our point of interest is P and we are here to find the slope at this point P, we will arrive to the definition of differentiation completely if I make this point Q close to P. That is, my final step will be completed if I bring these 2 points so close to each other that the distance between them is almost negligible. Why I am doing this? Because I am interested in finding slope at point P, right? That's why I will drag this point Q so close to P that they become almost equal. The best I can do is minimize their distance, right? If I minimize the distance between these 2 points, I will be successfully doing this. So that's why what I will do, I will tend this delta x towards 0. If I do this, this point P will completely come close, very close to P. And that's where I will get the formula of differentiation, which is dy by dx is equals to limit as delta x tending to 0, f of x plus delta x minus f of x divided by delta x. In some of the standard textbooks, we have seen that this delta x is replaced by h. H is nothing but the distance between these 2 points. It is so negligible that we will name it to be h. Okay. So this is also one of the formula. dy by dx is limit as h tends to 0, f of x plus h minus f of x by h. Next we will be looking at derivation of a formula of dy by dx of x square is equals to 2x. Every one of us know that dy by dx of x square is 2x. But why is dy by dx of x square 2x? We will find it out. So our function here is x square. Since we are interested in f of x plus h, therefore we will be writing f of x plus h as well, which is x plus h whole square. Now substituting these things in formula. So dy by dx is equals to limit as h tends to 0, f of x plus h is x plus h whole square minus f of x is x square divided by h. Now, before applying this limit h tends to 0, we need to simplify this as much as possible. Therefore, we will be simplifying this to the best of our extent. So, this will be a square plus b square plus 2ab, which is x square plus h square plus 2xh minus x square divided by h. Here x square and x square get cancels. We will be having limit as h tends to 0. In both of these, h is common, right? So, let's take h common. We will be left with h plus 2x divided by h. Here h and h get cancels. We will be left with limit as h tends to 0, h plus 2x. Now we will apply this limit. If I tend this h towards 0, I will be left out with 2x. Therefore, the differentiation of d by dx of x square is 2x. In the same way, we have calculated all the formulas, that is d by dx of sin x is cos x, d by dx of cos x is minus sin x, d by dx of x power n is n into x power n minus 1. In this way, we can derive all the other formulas. Next, we are going to learn one previous year question which was asked in IIT JEE 2022. But before going to that question, I want you guys to learn one result which will be helping for us to solve the previous year question. The result says, a function is differentiable at point C if it has unique tangent. Let us try to understand this by with example. Let us consider y is equals to x square. This is the graph of y is equals to x square. Let us consider a point 0. Now if I want to see whether the function is differentiable at this point 0 or not, let's draw a tangent. If the tangent is drawn uniquely at that point, then we say that the function is differentiable at that given point. Again, let us consider any random point of the domain. If I try to draw a tangent at that point, I am able to draw a unique tangent here. Therefore, the function is differentiable at any given point of the domain. Right? So, this is what our first result says. What if there is no unique tangent? What if we can draw more than one tangent? Then we say the function is not differentiable. That is what our second result says. A function is not differentiable at a point if it is not continuous. This is the first point of consideration. If function is not fit for continuity, then we cannot say it is differentiable as well. The next point says if it has vertical tangent or more than one tangent or its graph has sharp corner. We will understand all of these sentences only by taking the example y is equals to modulus of x, which is very standard example. So this is the graph of y is equals to mod x. Now this is not differentiable at point 0. This is not differentiable at point 0. Let us see why. Because it has no, see, if it has more than one tangent, that is more than one tangent means it has infinite number of tangents. We can draw infinite number of tangents at the point 0. Therefore, it is not differentiable. The other reason you can give is it has sharp corner. It has sharp corner. See, the function is going smoothly, but at point 0, it took a sharp cut. Therefore, it is not differentiable. But if a function is continuous, then we cannot say whether it is differentiable or not. But if a function is not continuous, you can definitely say that the function is not differentiable as well. Here, the function is continuous at point is equals to 0, but we cannot conclude anything about differentiability. So, if it is not continuous, then you can say it is differentiable. But if it is continuous, you cannot give any conclusion on differentiability. We are going to look at one previous year question which was asked in IIT JEE 2022. So, let's see what the question says. Y alpha is given to be under root 2 into tan alpha plus cot alpha whole divided by 1 plus tan square alpha plus 1 by sin square alpha. We need to find the value of dy by d alpha at point 5 pi by 6. So, let's solve. Now, everything is taken as it is. Here, cot alpha is written as 1 by tan alpha. It's very basic trigonometric formula, and 1 by sin square is also taken as it is, and even 1 plus tan square is also taken as it is. In next step, what we will be doing is we will be taking LCM. So, after we take LCM, it will become tan square alpha plus 1 into 1 by tan alpha. 1 by tan alpha is nothing but cot alpha. So, in next step, we are going to simplify and write it like this. Here 1 plus tan square alpha and 1 plus tan square alpha get cancels. We are left out with 2 into cot alpha, and the formula for cosecant square is 1 plus cot square alpha. Now this is in form of a plus b whole square, that is 1 plus cot alpha whole square. See, the basic mistake that we do is whenever we are given under root of x square, we will cancel this both, that is square and root get cancels and we will write x. This is very wrong concept. Whenever under root x square is given, we should write it as mod x. This is the right way to cancel it out and write, right? So therefore, under root of 1 plus cot alpha whole square, will be nothing but modulus of 1 plus cot alpha. Now y of x is equals to modulus of 1 plus cot alpha is not differentiable everywhere. We have already seen that in the result that we have discussed. Mod of x is not differentiable at point 0. Why it is not differentiable? Because it does not have unit tangent, or we can say it has sharp cut. Now 1 plus cot alpha is somewhere not able to be get differentiated. Since there is modulus applied on this function, we need to be careful before applying any differentiation. Therefore, to get where the point of consideration has to be taken, we will draw the graph. So let us draw graph for cot alpha first. So y is equals to cot alpha is given by this. That is, it is not defined in the area of pi and 0. Therefore, the graph of y is equals to cot alpha is given by this thing. The next thing is, actually we are interested in finding modulus of 1 plus cot alpha, right? So cot alpha is known to us. What will be 1 plus cot alpha? 1 unit it will get shifted. So that's why we will be drawing a graph of 1 plus cot alpha in this manner, right? Now look carefully. They have given our interval to be alpha is coming from the interval of 3 pi by 4 to pi, right? So if 3 pi by 4 is somewhere here, 3 pi by 4 is almost equivalent to 2.7 something. So if we are taking this area, you can see that the output of this function is negative. The output of this function is negative. Therefore, our y alpha will be coming out as 1 plus tan alpha is negative. Why it is coming negative? That's how modulus of function is defined. Mod x is defined as x if x is greater than or equals to 0 minus x if x is less than 0, right? If the outputs are negative, then we will take minus to that, right? We will put extra minus to that. So that's why here in the area, here in the portion where 3 pi by 4 and pi is lying, our output is negative. Therefore, we will be getting the negative of 1 plus cot alpha. Now this is fit for differentiation. There is no such restriction that can stop us by differentiating this function. Now let's differentiate. dy alpha by d alpha will be equals to minus of minus cosecant square alpha, which is a basic formula that we have to know. So this will be giving us cosecant square alpha. Now since they have said us d by d alpha at point 5 pi by 6. So we will be getting cosecant 5 pi by 6 whole square, right? Now this 5 pi by 6 is splitted into cosecant of pi minus pi by 6, right? Whole square. Now this pi minus pi by 6 lies in which quadrant? See, this is pi. Pi minus pi by 6 is lying in second quadrant, right? This is pi. Pi minus pi by 6 is lying in second quadrant. It is clearly noted. So, in second quadrant, cosecant is positive, right? If it is positive, we will be getting cosecant pi by 6 as output. So, cosecant pi by 6 is how much? 2. So, cosecant pi minus pi by 6 will be cosecant pi by 6, which in turn will give you 2, and here since it is square, it will be 2 square. So, it will be 2 square, which in turn will give you 4. So, 4 will be the final answer of this question. Thank you so much.